Okay, so guys, I'm audible to all of you. Uh, can you confirm the chat if I'm audible then? So can we start with the session? Just give me a quick confirmation. Can we start it or not? Okay, so let me share my screen and then we'll start with the session. Just give me a second, guys. I'm going to share my screen. Wait. Okay, so just give me a second, guys. I hope my screen is visible to all of you. Yes or no? Tell me, guys, fast. Just write it down in the chat. Sir, why the session are overlapping? Currently, DSA is also live. Okay. So DSA for what? DSA for the placement training? Yes or no? Tell me. DSA for what? DSA for the placement training. Okay. So basically, I was not aware about it, and I think I informed you regarding the session in my previous class only, right? I asked you, yeah, pre-placement training, right, Kriti? So I asked to all of you for this session in my previous class itself. So you told me like we are ready for that. So that's why I scheduled it. So guys, you are going for the DSA session or you are attending this one only project? That's why like people are very less. I was thinking that why people are not joining. Pre-placement training classes happen every days. Yeah, I know, Kriti, I know about it. So guys, tell me who is taking your pre-placement training right now? Okay, Priya Bhatia ma'am is taking your pre-placement training for the DSA. Fine, no issue. So guys, what we can do, uh, we can go with the project, right? And if you are attending the PPT session, you can, if you want to attend the PPT session, you can attend that, and later on you can watch the recording, right? So let me complete the like a project section. I think two project we have completed in our class. So guys, I think I have given you one task, right, in my previous session. Yes or no? Tell me, right? Can you tell me, guys, what was the task? What was the task basically which I had given you in my previous session? Please let me know. Please write it down in the chat. Tell me, guys, fast. Yes, I basically see. I solved one problem statement in front of you. Okay, and I have given you to convert that thing into an end-to-end project. So have you done that? How many people has completed that particular project? Please let me know in the chat. If you have completed, please let me know. I will give you the chance to represent in front of everyone. I will give you 15 minutes and then we'll go for the next project. So please write it down in the chat. How many people has created that project, that task, which I given in my previous session. Please let me know, guys. Okay, Devya Jyoti is saying 50% is over. What about others? Please let me know in the chat, guys. So just tell me, you completed or not? No, still watching old project recording. Time management is an issue. Okay, Kriti. So Okay, fine. And what about others? Let me know, guys, in the chat. Did you complete that or not? Please tell me. Okay, Manshu saying no, Akshay saying no. Okay, may I know the reason why? Because I think 1 week is enough for that. Not maybe even 1 week. Maybe like 2 to 3 days only. So why you didn't complete? May I know the reason in the chat? Data transformation is in progress. I think I've given you the complete solution. That why like you are taking this much time, guys. I didn't tell you to like add some more step in that. I just told you that just try to convert into an end-to-end project. And everything I have given from my side. Then why? So any reason for that? Okay, so Dev Jyoti, how much you completed? Please let me know in the chat. Please write it down here. Actually, sir, because the pandas profiling of code is lagging a lot, everything is working fine. Okay, so can you represent something as of now, at least a data ingestion or transformation or training part, if that is ready with you, and the rest of the project basically I will explain, and then we'll jump to the next project and next use case. Please tell me, Devjyoti. Actually, sir, I connected with my phone. Okay, great. You are learning with your phone. So fine, guys. I can see people are not serious here, and from now I won't give you any kind of a task, and I will explain everything from my side only. I think now you are happy, right? Yes, definitely. You can connect with the laptop, and we can like go with the project only. If you have completed some part of the project, if you have like code, if you have coded like anything in that, you can represent that. Yeah, sure. Okay, so guys, what we can do, we can go with the projects. First, we'll go with the see, Divyajyoti has created something in the project. First, like we'll see the like presentation of those section, those part, and then we'll go with the new use case. Okay, I will explain you the new use case, and then basically, one more class for the project, and after that, we'll try to complete our project section. Okay. So let me tell you what all thing is there. Just wait. Mm, yeah, Rusikesh, don't worry, I will give you the chance. Okay, I will give you the chance. Just wait. Okay, so guys, see, project wise, we have completed two projects as of now. Now I will like do two more projects in front of you. Okay, so we'll try to code it from scratch, and I will code in front of you only from scratch. And after that, whatever project will be there, you have to code by yourself, right? And that will be a task for you as as a like a project or as a task, right? Or as an end-to-end project, basically you can consider it. So we'll try to do four project here itself in the live session. So we have completed for credit card fault. and we have completed wafer fault detection. Now the next project, basically we're going to discuss this cement strength project, right? And after that we'll try to discuss this visibility climate. Okay, so cement strength and visibility climate, these two project. So in today's class we'll try to code a cement strength project, and in the next session we'll try to code visibility climate, right? And after that two project, so I think this fraud detection, basically it's a same project, this one credit card fraud detection. By mistake I think they have written over there 9th May. Okay, that project, basically you don't consider that project, it's the same one, credit card fraud. So what I will do, two more project I will do for you, and two project you have to do by yourself, and that will be as a task, right? Okay. No, fraud detection, it's the same one, credit card fraud and fraud detection. Okay. So just this two, first for the 8th May and the second for the 9th May, right? So which has been given over there on the dashboard. So this 9th May project, basically what they did, by mistake they have written a fraud detection, but it's the same one, credit card fraud detection, right? So this project, don't consider this project. We just have 6 use cases, and two use cases we already completed, two more use case will do, and two use case will be for you. Okay, guys, do you agree, or is it fine for you? Yes, right. So, Divya Jyoti, I can give you the access, and I will give you the 15 minute of time. Within that, you have to explain the entire pipeline. You have to explain the use case and how you coded the end-to-end pipeline. You have to discuss. You have to talk about that also. So let me give you the chance, and please do it. Divya Jyoti, am I audible to you? Please do confirm in the chat. Divya, are you there? Can you hear me? Hello. You are not audible, Divya. Divya Jyoti. Divya, are you there? I cannot hear you. I think something is wrong with your microphone. Please check. Himanshu, I'm audible to you. Himanshu Nima, can you speak something? I think I'm audible, right? Or some issue with my mic. Can anyone hear to like anyone? Like Divya or Himanshu? Please confirm, guys. Please confirm in the chat. Okay, I'm on audible. Yes, I think Divya Jyoti, something is wrong from your side. Please check with the microphone. No, still you are not audible to me. Please check once again. Hello, Divya. Just check with your microphone. Just check with the setting of the system. Select a speaker, select a microphone. There is two options. So just check with that. You selected a correct option or not? That is the issue, basically. Okay, fine. I think Divya, you are not audible. Please check with your microphone and then let me know, okay? Because I cannot waste too much time. Okay, so guys, Yeah, some issue is with you. So don't check with a headphone, microphone, or whatever. Just try to use the system microphone. Maybe it will be working. So just give me a confirmation. I'm giving you 1 minute of time. Otherwise, I will start with the session. Yes, giving you 1 minute. Just check with that. Okay. Okay, fine, guys. So I can start with the session now, and uh, fine. So just check with the microphone, and if it is working, then let me know, please. So, guys, in the previous session, we were talking about the problem statement, and the problem name was credit card fraud detection, right? Let me show you that problem first of all, and then we'll go for the the end-to-end pipeline of the project. Within half an hour, I will give you the just a quick revision for that pipeline, which we have created in our previous session as well. And then we'll try to go with the new problem statement, and that is a cement strength, right? And then finally, we'll go for the next one. That will be our end. That will be our last use case, and then two use case I will give you as a assignment. Okay. So what we can do, we can I can open my VS Code. In the VS Code itself, I will explain you the entire pipeline, right? So just allow me a minute. Let me open this one. Mm, Okay, so guys, here is the complete project, right? Now in this project, you can see it's the same, right? It's the same like previous project. Now here, what we are going to do, we are going to create a model and we are going to serve that model as a web application, right? As a web API. So this each and everything, if I have explained you in my previous session, if you will check with that session, you will get to know each and everything, right? Now here you can see we have a notebook, we have like a SRC folder, we have this static folder, we have template, right? And we have upload data to DB. There I have written a script for the MongoDB, and then we have Docker ignore, Git ignore, right? And app.py. There we are going to create our a Flask application. And here what we have a Docker file, all right, and in that we are going to write a code for creating a Docker image. So this each and everything I have explained you in my previous class also, so I'm not going to explain you again and again. I'm just going to explain you the complete pipeline, and then what you need to do, you need to run this project and you need to let me know like everything is fine for you or not. Okay. So from next project onwards, I will give you like some like a more detail with respect to the MLOps tools, or I will give you some more idea with respect to the different tools which you can integrate inside your inside the inside this pipeline. Okay. Now, for the two project, this one and the previous one, the pipeline will be same. But if you want to add on few more thing, then definitely you can add on. But as of now, I'm not going to teach you because it might be difficult for you to understand. That's why I have given you to I have given you to one project. So you need to code that one, but you didn't. So first of all, code this one, and in the next class, I will teach you like some more tool so that you can integrate inside your pipeline. As of now, guys, what you can do, so just go through with this project which I have created for you, a simplest one, right? And if you didn't code and if you haven't code, then what you can do, you can take a reference of this particular project and you can complete that, right? Now here, what we have, so step by step, let me explain you everything, and then we'll come to the next one, that is a cement strength project. So here I can share my screen, whiteboard basically. I can give you some sort of an idea, right? The same thing which we have done in the previous session as well. Okay. So I hope it is visible. Can you confirm in the chat? Please do confirm, guys. Okay. So guys, here. mm, Okay, so guys, see, whenever we are going to create a project, whenever we are going to create a project into machine learning, so we have like a certain step which we have to take care. So generally what we do, we create a pipeline, okay, and the pipeline basically we code two things. So the first thing which we generally code, that is our training pipeline, right? We generally code our training pipeline, and the second thing basically which we code, we always code our prediction pipeline or testing pipeline. What we code, guys, tell me. We code always our prediction pipeline. So training pipeline and a prediction pipeline. Now, what is the meaning of the pipeline? So if someone is going to ask you now, Sunny, can you tell me what is the meaning of the pipeline? So pipeline is nothing. Pipeline is a set of the component, right? What is this? It's a set of components. Okay, set of components, right? Now here we are talking about a component. So what is a component, guys? So component is nothing, it's an individual process, right? So here let me write it down. What is a component? So set of components. Okay, here I'm going to write a set of component. Now what is a component? So component is nothing, it's a set of the it's a like it's what is this, it's a like an individual process, right? So we have a different components, which we can write it down, which we can code during our pipeline. So the first name of the component, that is called a data ingestion. From basically we are going to ingest our data. So that is what, that is a data ingestion. Now the second is what? Now the second is called a data transformation. Okay, data transformation. And after that, what we have? After that, we have model training, right? So the third one, we have model training. Okay. And the fourth one, what we have, tell me guys, model evaluation. So these are the steps which we have, right? So these are the steps which we have, and we generally, this is called a component. If we are going to connect this component, if we are going to make a sequence from this component, so that is called a pipeline. So one right after another, right? So this one, this next will be right after first, and this one right after second, and this one right after third one, right? So this is called a component, right? Here I'm going to write a data ingestion. There I'm going to use MongoDB for what? For my pipeline, for my data ingestion. Means I kept my data over here, and what we are going to do, we are going to collect my data for the process, right? Now here, we are having something basically for like infrastructure. If we are going to code our infrastructure, so we have something, right? So let me write it down over here. So the first thing which what we do, we always package our project, right? We always package our project. Okay, so the component which we have, we always package that component. Now here is a question for you. Which file we need to create for packaging our project? Tell me guys. Which file is required for packaging the project? Anyone would like to answer to this question? Okay, so which file is required? Someone is saying YAML file. That's great. Someone is saying requirement.txt. That is absolutely great. Someone is saying setup.py. Kriti is saying setup.py init. That's correct. And someone is saying utils file. So guys, what you are doing, we already completed one project, right? And in I took 4 sessions for that project. I can complete it within a 1 days also. I don't know what people are doing. Someone is saying YAML file. So why, how to create a package with the YAML file? Did I teach you that, Akshay? Someone is saying required.txt. How? Required.txt just to install the packages, external packages. But if you want to package our project, okay, that is a process of the machine learning project. So for that, we are using setup.py file. Okay. And wherever we have init.py, so that folder is going to be considered as a package. So that concept I clarified with all of you. but guys, you are not revising the thing. That is very, very bad. So setup.py file we use. Okay. Now tell me guys, what we do, we create an environment also, virtual environment. So what we are using for creating a virtual environment, we are using Conda, right? We are using Conda for creating a virtual environment. Now we use requirement.txt file. Why we use it? For install the external packages, right? After, apart from that, this for the internal package. Means if you want to if you want to treat our, if you want to treat our like a folder, this src folder as a package, this component as a package, so we use the setup.py file environment we create. We have a requirement.txt. Okay, then for the containerization we use a docker also, right? Docker, right? So a docker also we use requirement.txt environment packages, right? Now if you want to log something, we use logger. If you want to find out exception in the project, we are using exception handling, right? We are using exception handling. Logger is there, exception handling is there, right? Apart from that, so these are the things. So we are using utils files for the utility function, utils file, okay, for some sort of a utility, right? So whatever utility is there, for that we are using this utils file. So package, environment, requirement, docker, logger, exception, utils. Do you are you remembering something? Please let me know in the chat. Are you remembering something? Yes or no? Tell me, guys, fast. Yes. So this is what, this is the complete project. Now, after that, see, what we did, we learned a different stages of the project. So what we did, so first we went to the development side, right? First we went to the development side. Here we developed the entire code and we were integrating the entire code where we were integrating the entire code in the Git. Okay, through the Git, basically, we were pushing the entire code in the GitHub. And for the GitHub, basically, what we were doing, we were using the GitHub Action Server, right? GitHub Action Server, GitHub Action Server, and we were trying to like deploy our code to the AWS. And in the AWS also, we were using the containerization concept, we were using the virtual machine concept, right? And each and everything I have explained you in my previous project. Yes or no, guys? Tell me. All right. So each and every concept we had talked about in our previous session. Uh, I believe you remember all the things. Just give me quick yes or no in the chat. So any doubt, anything so far? Please let me know. Yeah, I know, guys, you are not learning properly, but so fine, guys. I'm here for you. I will explain again everything. Not an issue. Tell me, guys, anything? Uh, any doubt so far? No, right? Okay. So guys, what we can do now, again, we can go to the project and let me show you the pipeline over here. So the project wise, the pipeline wise, nothing is here. The same thing basically. If you will go into this SRC, so we have a component. Okay, we have a configuration of the component, right? So artifact and configuration, there's a two thing of the component which I explain you, right? Here, what we have a constant. So constant is nothing. It's like a variable itself. Whatever variable you are using in your project, so those variable we are going to define in our file, okay, in like a separate file. So that is what, that is a, that file basically it's a constant. It's a standard practice whenever you are coding something in the for the production, or whenever you are coding something for the and in the like for the production or in the real time. So there is some protocol which you need to follow. And this constant like this kind of a file, utility file, constant file, configuration file, maybe you will be generating, or maybe you are going to write those files for the project, right, inside the project. Now here we have a pipeline, so training pipeline, and this one prediction pipeline. We have a utils like find main utils is there, exception is there, logging is there, static and template just for the front end, right? Here we have a script for the upload data. You can upload your data in the MongoDB. We have app.py file, okay, Docker file. So just go through with this project. You will get each and everything. And believe me, it's not that much stuff. It's directly related to the from the previous project. We haven't added anything new over here, apart from the use case. So getting my point, guys? Yes or no? Tell me. Yes or no? Okay, fine. So I will give you this project. You need to follow it, right? So Devjyoti, now can you showcase your work, whatever you have done. I'm giving you 15 minutes of time. Then from 9, we are going to start a new case study. Just tell me, Devjyoti. Okay. So I'm giving you the chance. You can unmute yourself, and if everything is fine, then please share the screen.
Yeah, hello, sir. Am I audible?
Yes. Now you are audible.
Okay, sir. Just give me 1 minute. Let me connect to my laptop.
Yeah, yeah, sure. Okay. Okay, so guys, so uh, like Dev Jyoti will represent the project, and why I'm doing it because see I told you, right, so you need to do it, and you will get some sort of a motivation that yes, people are doing from your batch, so rest of the people also will get motivated from there, and usually I do it in my every batches. So yes, Dev Jyoti, please go ahead. I'm adding in a panelist.
Hello, sir.
Yeah, hi, Devjyoti. I think you are in. Now you can share the screen. Please start sharing, and you are audible also. But there is some echo. Please check with that.
Yeah, hello, sir.
Yeah, please share the screen.
Yeah, I think it's now visible.
Yeah, it's visible.
Okay. Just let me big my screen. Yeah.
Yeah, it is.
So,
Yes.
sir, after modeling my data,
No,
uh,
like explain from scratch, like from the problem statement to like whatever you did. Okay.
okay. Sir, as you
Okay,
know that,
it is not for me, it's for everyone. So everyone has joined here. So you are representing to everyone that, okay? Yeah.
okay, sir.
And guys,
Uh,
if you are having any kind of a doubt, so Devjyoti will be up for the doubts also. You can ask your doubts. Yes, please go ahead.
Okay, sir. So, as you all know, this is a credit card fault detection problem. So it's our classification problem. It's either your credit card is fault or not. So you have two choices. One is for fault and zero is for not fault. And here is a basic EDA or model training that sir did in previous class. So I'm not taking that much of time. So in the other yes, in the other I other that's what is called Jupyter other notebook. I actually post all the data to my MongoDB. So first I read I extract the data from this link and post the data by using my Mongo, PyMongo and Mongo client. So in that Mongo client, I used ML project and our credit card project. My database name and collection name is credit card fault detection. And yeah, so I transfer all my data to that MongoDB my MongoDB database and pull the data. I created another my notebook. In that notebook, I extract all the data from my database MongoDB. So here you can see actually I used find for find first I used find function to collect all the data, to extract all the data, and convert that data which is in which in JSON format to list, and list to our data frame format. Then this is our final product that I extract from that MongoDB. Now I created actually that data my program structure, project structure, src file. In src file I created two more file. There's component folder and pipe folder. In inside src folder there is I created another three files, that init dot py file, exception file, logger file, and util file. Okay, so for in component file, I created three files, that data ingestion, data transformation, and model training py. For pipe folder, I created two more files, that predict pipeline and training pipeline, and this requirement.txt file, and this setup.py file. Okay. So okay, that's great. Ignore it. It will ignore all that my BNB file. Okay. Okay. Now let's go to data ingestion. In data ingestion, actually, as we all know, in data ingestion in data ingestion file, we have to extract that extract all that our data information, and store in the artifact.py artifact folder. So I created first in first I imported logging from the logger file, custom exception from the exception file, and export collection data frame from util. Actually, I created another code here to extract all the data from the MongoDB database. Use the DB and collection name. It will this will help to extract all the data from our for my MongoDB database connection. Yes, MongoDB database connection, and drop if there is an ID. Let me show you. Yeah, as you can see here, that ID there is another column is all with that my data file, and there is another column also extracted, which is ID column. So I drop that ID column here, drop that ID column here, and replay. And if there is any if there is any null value, it will be replace that non values. And yeah, it's convert to it's now it's extract to our data ingestion file. Okay, and I also import trend test and trend test split from the sklearn, import pandas, numpy, and data class. So in that first I created a class with name of data ingestion configuration. Here I created three path: trend data path, test data path, and drop data path. So in draw data path, actually it which data it will be extracted from that data from that MongoDB. It will be fully all the data are stored in our raw data path. And after train and test split, these data will be stored in the train data path and test data path respectively. Okay, so another I created another class data ingestion with that I created another function name initial data ingestion. In that initial data ingestion, I used a try exception handle. With that inside the try exception handle, I used I collect all the data. Actually, this export collection as data frame, which is util.py. This is here it will be take my database name and collection name, which is credit card fault detection, credit and transfer, it will be transferred into my data frame. Okay, and then I use it login information, which is exported collection as data frame. Then I used to make dir. Actually it will transfer all that my raw data to the my artifact folder. Then I use my trend test split, which is which have test size of 30% and random set of 42. It will be train and test, split my data into sets and test sets. Okay, and this trend sets and test set will be stored in my artifact folder. Okay, actually after that I in this pipeline I use the trend pipeline. This trend pipe, it will be okay, it will be used, this trend pipeline, it will be used as a as an what you call run my data ingestion file. Okay, here I transport, here I transport all my uh, data ingestion class, and in data ingestion class I use trend data path and test data path with object dot initial data ingestion. Okay, inside the initial data ingestion I print the trend data path and test data path. Actually sir, i did um, I did this much. Actually I didn't run this code. Hello sir.
Yes, Devjyoti, yes.
Okay sir, sir, I did this much, so
Hmm.
actually I haven't run this code till now. Can I run?
No, definitely it's your code, right? So why should not you should run it basically. Yeah, please go ahead. And you did you code the data transformation and model training py dot also?
And data trans, no sir, just data ingestion.
Okay, that's great. But yeah, I think you got the entire like a structure or an entire pipeline, and you did a good job. Okay, so just try to create this. Just try to code this two module also, data transformation and model training, and then finally deploy it also. Okay.
Okay sir.
Yeah. So guys, how's the project? And yeah, tell me guys in the chat if you are having any sort of a doubt, and how much you would like to rate to Devjyoti efforts. Training pipeline.py, that is a file name.
Training pipeline dot not py.
I think it is saying data ingestion at object has no attribute initiate data ingestion. Just check once, did you created a class or not, or maybe there is name, the name is different over there. Okay, so guys, please do it, and you will also get a chance to represent the project. And yeah, I think it is not that much tough. It's a easy thing. Just you need to do by yourself. That's it.
Okay sir, this much I did. So can I
Yeah.
start?
Please, like, yeah, just fix it and try to code other like module also, the two other component also, and then finally deploy it and send it to me on my mail ID. Okay.
Okay sir. Sir, can you again send your email?
Yeah, sure. I'm sharing in the chat.
Okay sir. Thank you.
Yeah.
Start.
Okay, so fine, guys, we can start with a new use case or a new case study. That is what? That is a credit card. Sorry, this is a cement strength prediction project. Okay, so guys, open your Jupyter notebook and then there we'll try to code the entire thing. Okay, so guys, please open your Jupyter notebook and let me share my screen as well. Just wait. Okay, I hope my screen is visible to all of you. Can you confirm in the chat? Fine, guys. So we are going to start our new case study, and that is what cement strength prediction. Let me give you the data first. So I'm sharing the data with all of you. Just wait. Mm, Yeah, I'm sharing the data. Just wait. Okay, so I'm sharing the link with all of you. From here, you can download the data. Please let me know if you got the data. Just do confirm in the chat if you got the data. Guys, please let me know in the chat. Got it? Yes or no, guys? Please let me know. Why so? Why? This is the link, na? Just click on that. Click on the link. You will get this kind of a interface here. You can see this one. Just download it from here. Cementdata.csv. I given you, na? See? What is the issue? Just click on the link. Oh, fine. So guys, what we are going to do, we are going to solve this case study. And here what the first thing, what I need to do, I need to import the data. So for importing the data, I'm going to write import pandas as PD, right? So import pandas as PD. Now what I'm doing, here I'm going to write PD dot read CSV. And here I'm going to write a file name. So my file name is what? Cement underscore data dot CSV, right? So this is what? This is my data. And in that we have a different columns, right? So the first column is what? A cement, okay? And component one, okay? That is component 2, component 3, component 4, component 5, component 6, 7, 8, 9. So on 9 column they have given to us, and here this is what kilogram in MQ mixture, right? So this is what, this is a some sort of a like unit part they have given with respect to the cement, right? So how much blast furnace slag is there, fly ash is there, how much water is there, how much super plasticide is there, okay, Coras aggregator is there, fine aggregator is there, right? Age is there, concrete compressive strength is there. So different column is there inside my data. Can you see this one? Tell me guys, can you see this one? Yes. Now based on which column? Uh, Excuse me, sir. Can I explain? What do you want to explain? Rushikesh, wait, I'm giving you the access. Just wait. Yes, tell me, Rushikesh.
Hello, so evening, sir.
Yeah, good evening.
Actually, I am from a civil background. So
Hmm.
can I explain the features of the respective data set?
Yeah, definitely you can like talk about it. Please let
Okay,
me.
okay, okay.
And here, guys, yeah, just wait to see. See,
Uh,
whenever you are working on a data science problem, right? So there must be like any domain expert who will
yes,
help you with that.
yes.
So yeah, Rishikesh, please go ahead.
Okay, okay. So with respect, so first of all, evening all. So sir, if you give permission, can I share my screen so I can share the entire process with respect to internship project, or should I explain
No,
this?
just explain the data as of now, okay? Because I need to complete this case study, and
Uh,
then later on I will give you the chance, then you can explain.
Okay, okay, okay. So, with respect to that, we have actually 1, 2, 3, 4, 5, 6, 7, 8 independent features up till age. And final, the target feature is concrete compressive strength, which is in megapascals. So, megapascal can be represented as Newton per mm square also. So, with respect to that, means 1 mm by 1 mm square. If we take the that particular square surface area, the load should be taken with respect to that concrete, it is 1 Newton itself. So that is 1 megapascal or 1 Newton mm square. So the unit of each feature, each independent feature is given then in kg per meter cube. If we explain that, means if you make the cube of 1 meter by 1 meter by 1 meter, and if you pour the cement or say any material with respect to that, so that particular material should weigh that particular weight. So with respect to cement, it is 540 kg for particular making that strength of concrete. So with respect, the cement is kg per meter cube. So that is the idea behind it. Kg per meter cube means if we make the 1 meter by 1 meter by cube and pour the material, it should weigh with respect to that compressive strength. So cement is the main ingredient to predict our compressive strength. If you means I'm just telling you, because if you plot the correlation between the cement and compressive strength, it should be greater. So another material is blast furnace slag. So what is blast furnace slag? So if anyone is from mechanical background, they will know it. When we do any iron processing or the metal processing, with respect to that, some slag is remain, or say remaining of the say byproduct of that material, steel is remain, or say any metal is remain. So that is blast furnace slag. So it's come from the furnace, or say in Hindi or Marathi say it bhatti mein se aati hai wo hai blast furnace slag. Then the third component is fly ash. Fly ash is the byproduct or remaining after of the coal. Coal means it is coming from electricity production, or say any other industrial process after burning the coal. The remaining is fly ash. Then water. No need to explain. Super plasticizer is the chemical material which is required to lessen the amount of water. Or why lesser the amount? Because if we pour more water, the cement paste will get thin, and it will directly affect the compressive strength. So super plasticizer saves our water content and helps to gain more compressive strength with respect to it. So it is a chemical. Generally, super plasticizer is not compulsory added but to with respect to some enhanced qualities of concrete, it is generally used in concrete mixing process. Next material, coarse aggregate. Now, coarse aggregate and fine aggregate are the natural ingredients which are chemically inert or should be chemically inert. They are generally used to just increase the volume and avoid cracks within the concrete after casting. So with respect to that, coarse aggregate is generally made from the boulders, large boulders, and it is from generally from say basalt rock. So this is from basalt rock generally. So this is the coarse aggregate, and fine aggregate is fine aggregate is in previously the fine aggregate is directly taken from the river flow, but generally nowadays fine aggregate is manufactured within the industry itself. It is also created from basalt rock. So the difference between coarse aggregate and fine aggregate is with respect to size itself. Fine aggregate have size almost 4.75 mm less than, sorry, 4.75 mm or less, and coarse aggregate has size of at most 20 mm with respect. And the age factor, so in this project they are taking the age at almost 28 days, but if we already know, the age can be calculated in 3 phases. First, at 7 day, which after casting at 7 day, the concrete gains the strength of almost 70% of the total entire life. At 14 days, it gains almost 90% of the entire strength, and at 28 days, it gains almost 99% of the entire strength. And these are the strength itself. So this is the explanation with respect to all the features within the data set. So it is okay, sir? Hello?
Yeah. So Hrusikesh is very like a comprehensive like explanation. That's great.
Okay, thank
I
you, sir.
hope like everyone got now, right? Can you give me a quick yes or no in the chat? Tell me, guys. Yes, I think so. Everything is clear with respect to the data. Or should I explain anything now? I don't think so. Because say I'm not a domain expert. I'm a techie, so I can solve a problem with the coding and all. But yeah, the problem basically the this one data set has been explained by Hrusikesh. It's amazing. Yep, it's very good.
Thank you, sir. Thank you.
So thank you, Hrusikesh. Now we can start with the problem solution. So for the problem, what we can do, first we can analysis the data, because that is the first step. That is the first step whenever we are getting any kind of a data or any sort of a data. So we have to analysis the data, right? And for analyzing, we are having a different library, different like a library in the Python itself. Okay, like NumPy, Pandas, or some other library. So we are going to use those library. Even we are going to use statistic concept as well for analyzing the data, right? So now what we can do, we can write some sort of a code. And here, okay, so first of all, I would like to ask to everyone, can you tell me the target feature here? What is the target feature? Which one is a target feature? Please tell me. Anyone? Just guess about the target feature. Which one is a target feature? Target feature is the strength of the cement. Correct. Okay, so I hope everyone is getting that. So many answer I can see in the chat. So what is the target feature? Target feature is a concentrated concentrate compressive strength. Okay, that is being calculated in the megapascal. Right. Fine. So that is a classification problem or regression problem statement. What do you think, guys? What is this? It's a classification problem or it's a regression problem statement. Please let me know. I think it is a regression problem statement, because our target feature is what? Our target feature is a numeric feature. Okay. So we can start. So first of all, guys, what I need to do, can I check? Okay. So here you can see each and every column is a, tell me, each and every column is what? numeric column. So first we can check with the first I can keep this data into a variable. That is what, that is my data. Okay. Now here what I will do, here I will write a data.info. So it will give me the entire information of the data. So you can see we have an information of the data. So should I need to do a typecasting with respect to any variable? I don't think so, right? We no need to like do a typecasting with respect to any sort of a variable, because every variable is like float, right? Now what we can do here, we can check with a null value. So for checking with checking with the null value, so I need to write a data dot is null, and it will give me the information of the null value. But I don't think so there is any null value. Let me write it on the sum over here. So if I will write sum, so here you can see we don't have any kind of a null value, right? So this two-step is clear. First, we need to check the detail of the data, and then we need to check the sum of the values. Yes or no? Just give me quick yes or no in the chat. Yes. And how many people are doing along with me as well? Hmm. Okay, great. So here each and every column is a target, each and every column is a numeric column. So let me check over here something. So what I can do, so for with respect to this kind of a data, if your column is a if like your entire column is a numeric column, so first of all check with the like a distribution of the data, right? So what kind of a distribution you have with respect to your data. So what you can do here, you can import a Seaborn as SNS, right? Now here you need to write SNS dot dist plot, right? So if you are going to plot this dist plot, so let me write it on the name of the column. So let's say if I'm having a column, the column name is what? The column name is this one. So with respect to this column, I'm going to check the distribution of the data. Okay. But my data set is very, very small. Let me show you once. Here is my data, and you can see the distribution of the data. So likewise, you can check with respect to each and every column. And for that, what I'm going to do, I'm going to run a for loop. So here, if I'm going to write a data dot columns, so what you will get, you will be getting all the column names, right? So here what we have all the column name, as you can see, right? Now what we are going to do. So here basically I'm going to take each and every column name, and I'm going to check the distribution of the data, right? So let me take those names. So for I or column in data dot columns, and here I'm going to write a print column. So I will get each and every column over here. Now I need to, what I need to do, I just need to put this name over here. So SNS this plot. So here I'm going to copy it, and let me do one thing. Let me paste it over here, and here I can provide column, right? I just need to write column over here. That's it. Now, guys, you will see that we will be able to plot with respect to each and every column. Okay. So why it is not plotting? SNS dot this plot. Okay, I think I will have to write plt dot show. And here I will have to import matplotlib dot pyplot as plt. So guys, here you can see each and every distribution of the data. So the first one is what? So guys, tell me, in the first one, in the first distribution, do we have any kind of outlier, or what do you think, guys, with respect to this distribution? Is it fine or it is not fine? What do you think? Yeah, we'll check with the duplicated value also. I think it is fine, right? So we don't have any kind of like outliers, I don't think over here, and it is following a normal distribution as well. Now, once you will check with so like just check with the next one. So here you can see it's kind of like an outlier or right skewed data. So we have many columns or many like data points over here, which is which is showing me here itself, and that is the right skewed. Now here you will find out some other. So it is a bimodal. So we have like over here you will find out. So this is the first distribution, and this is showing a second one, right? Now once I will scroll down, so here it is showing a kind of a normal distribution. Okay. And here also it is a bimodal and normal distribution. And here is a right skewed. So in that we have like a few this one also. What? So we have like this outlier as well. So once you will check with this one, okay. Now what I can do, I can use the same like a library which I used in my previous session. That was the pandas profiling. Okay, so with that you will get some basic information which I don't want to write manually. Okay, and when I will directly jump to the model building, right? So here, could you explain in canvas and matrix format? Mm, no, I didn't get you, BD. So here what I can do, I can use the pandas profiling for getting a basic description regarding the data. Okay, if you want to use pandas profiling, so there is very simple code for that. Let me show you with the pandas profiling library. Now here you need to check with the previous version. Okay, so let's say like a 3.5. Let's take this one. And here you will get the code as well. So what you need to do, you just need to import this pandas profiling. So let me import this pandas profiling, and then basically I will try to code it. So here is what, here I'm going to import it. And then basically I'm going giving my data to the pandas profiling like a class. Okay, sorry. Here I've given the like a data. So it's not a df, it's a data. Okay. After that, what I will do, I will just call this simple function in which format I want to check with my report. So I want to check the report in widgets. Okay. So here I'm going to call this widgets. Now, once I will call this thing, and I will automatically get my all the information with respect to the data, or all the data analysis over here itself. So it is preparing the report. And if your data is too heavy, or if your system is too like with the low configuration, then it might not be work in your system. It may hang, right? So please use carefully with the big data and with the low configuration system. Okay. So guys, just wait. It is going to be it is running everything. See, if each and every check, each and everything, basically you can check manually also. Means you can write a code in the Python for the duplicate, for the data profile, for the like visualization, right? But we don't want to be, we don't want to waste our time over here. Instead of that, what we are doing, we are just checking the entire information over here, and then directly we'll try to build a model. So this is the basic profile of the data, 9 column, and here you can see 1,000 rows. Once you will check with the variable, so these are the variable, and this is the derivative or like a distribution of the variable. Now, someone was saying, do we have duplicates value? But like I don't think we have a duplicates over here. So missing value is 0, and negative is not there. Okay, you can check with this particular column also. So zeros is this much. So we have this much zeros over here, and it might be 0 as well. Okay, so zeros value is here. This thing is 187. Okay, so this thing value is what? Which one? How much? 187, right? Now fly ash. So fly ash over here, you can see this here is also, we have lots of 66 zeros, right? Mean is this much. There is no infinite value. There is no missing value. There's a distinct count. Now here is a water. So with respect to water also, we have like a data. Now with respect to this super plasticizer, this for this with respect to this one also we have a data. Okay, course aggregated with respect to this we have a data. Okay, and similarly with other column. So you can check, guys, you can run it and you can analysis your data over here. Now overview is done, variable is done. Now interaction. So if you will check with the interaction, so you will find out a different graphs. So here is a graph, and that is what, there's my bubble chart, right? Now here you will find out some sort of a relation between values. So here you can see the value is more concentrated over here compared to this one, right? We are doing an analysis between these two columns, right? Likewise, you can do with any column. Okay, and here what you are getting, you are getting this a particular relation, and this is what bubble chart, right? Now interaction wise is fine. You can make an interaction between two column and you can find out a result, right? Now apart from that, what you can do, you can check with a correlation also. So here is a correlation between a variable, and here you can put the here you can put the threshold also. So if you want to, if you don't want to do, if you don't want like a multicollinearity inside your problem, so here you can put the threshold on part, and you can check with the BIF score, and whatever like column you are going to whatever column you are going to select, you can put the threshold on top of that, right here itself. So here we have a correlation. So you can see our correlations, and it is a correlation between like a numbers, okay, between some sorry, between this column, right? Now here we have a missing value, so you can check the missing values. We don't have any missing value, so okay. Now sample wise, so here is a sample of the data which they are showing, and here is a duplicate rows. So I don't think okay, so we have a duplicated row. So total how many duplicated rows? 10 duplicated rows is here, right? So guys, if you want to check the duplicated rows, you can check it over here. What you can do, you can write data dot duplicated, right? So once you will write it down, duplicated, and here let me run it. Here you will get the values. Now here let me write it down the sum. So we have a 25 duplicated rows. Okay. So how many duplicated rows, guys? 25 duplicated rows we have. So we can write drop duplicates, we can drop the rows as well, and or else what we can do, otherwise we can take the same data, okay, because the duplicated rows is very small over here. So if you are having a lots of duplicated rows, so in that case what you can do, you can drop the duplicated rows from the data, okay. So here what we have seen the overview of the data. Now here is a like some sort of a warning reproduct, okay, reproduction is there. Now here what we have a variable, okay, we have checked the different variable, we have seen the interaction, okay, with respect to each and every column. We have seen correlation, missing value, sample, and duplicated rows. So these are the part of the analysis which we have done so far. If you want to do like a more analysis based on your based on your understanding, you can do that, right? But let me give you the basic idea with respect to the analysis, like how you need to proceed if you are doing any sort of analysis, okay. So whenever you are doing a EDA, so you should remember a few points while you are doing a EDA. So the first thing is you need to create a basic profile of the data, right? So whenever you are going for the EDA, so what you need to do, guys, you need to create a profile of the data. In the profile, can anyone tell me what all thing will be there? Tell me, guys, please let me know in the chat. I want at least 5 points from everyone's side. Tell me, guys, what all point is there whenever we are going to create a profile of the data? Tell me, guys. Please write it on the chat. I'm asking about profile. Yes, anyone? So basic profile means how many rows is there, how many columns is there, okay, how many duplicated values is there. One check with this one, na. See this pandas profiling, guys. I think you are not practicing with your like concept. See, if you're not clear in your mind now, you cannot do analysis and on top of the data. It will be very hard for you. So this is the basic overview of the data or basic profile of the data. So here what you are seeing, number of variable, number of observation, missing value, duplicated values, right? So these are the like a basic analysis of the data. Okay, so basic analysis of data. You are how many column is a numeric one, how many column is a categorical one, right? There is any duplicate row, how many size in the memory. Then basically you need to come to this graphical analysis, stats based analysis or graphical analysis. In the see this graphic stats based analysis, statistic based analysis, you can perform with the graph also, right? So the statistic based analysis, what you can do, you can perform with a graph also, right? So graphical analysis or statistic based analysis, then you need to focus on top of this. Here you are going to talk about a basic statistic of the data, right? Mean, median, mode, and then after you need to check with a different Z score, TT score, categorical chi-square test or ANOVA test, F test, right? You can check with anything over there. You can make a hypothesis, you can check it. Then you can check with a dispersion of the data, right? Or the same thing, stats-based analysis, you can do with the Python, basic Python script, or the same thing you can do with the graphical representation also. Like say you want to find out a correlation. So you can plot the heat map over here as you can see this one, or else what you can do, you can write a code as well and you will get a numeric value that will be a correlation, right? So the thing should be clear whenever you are doing analysis of the data, and it should be an extensive one, right? So analysis in while you are doing analysis, the first thing is what you need to do you need to create a profile of the data, and that you will be having a basic information. How many like columns there, how many categorical numerical columns there, is there any missing value, is there any outlier, right? So that kind of a analysis, the basic like you can perform the basic overview, right? And then basically you need to do a EDA, stats based analysis, or like a graph based analysis, right? So based on that, you can explore more and more about the data, and it should be an extensive one. Okay, if you want to become a good data scientist, you should have a good understanding of the EDA and pre-processing of the data, right? So here we did a basic like a basic pre-processing of the data. Now what we'll do, without wasting a time, we'll go for the we'll be going for the model building. Okay, so till here everything is fine, guys. Tell me everything is clear so far. Just let me know in the chat. Yes or no? What to do with the outlier? What you will do with the outlier? Please tell me. If you are having outlier, so what you can do with the outlier? Please let me know in the chat. Yeah, you will handle it, right? You will drop it, you will handle it, you will convert the value into other values, right? So we are having many thing with the for the outliers, outlier handling. We have many like outlier handling technique. I think Chris sir has covered those part. Chris sir has already told you those part, and he has talked about the outliers, right? Let me know in the chat, yes or no. If feature are non-normal distributed, then you will transform the data. You will use either you will use long transformation, or you will use box transformation, or you will use like square root transformation. Okay, there is a technique how to transform it. So there's a code, right? There's a like there's a formula. So if you, so let's say like your data is like this, or non-normal distributed. So you, what you will do on top of this one, you are going to use log. Okay, and you are going to transform your data, means from norm. Now see, this is what is happening. So here, let's say this is the data. This one. Now it is what? It's a right skewed. Let me draw it again. This is the data, right? Now what you will do? So this data basically you are going to apply log on top of this log formula, and you are going to transform it. Okay, we are having many functionality, many like a function for the like a transformation. Okay. Now what we can do, guys, see, we have we did our basic analysis, and there is nothing in our data. The data is very simple. The data is not that much complex, right? So here what we'll do, we'll try to create a model directly. Okay, and we'll try to analysis with a different model, like how much accuracy and all we are getting. Yes, it might affect to every model, and we need to check the like a linearity also between a model. Is it linear or not? Okay, so for that basically we can plot the scatter plot, right? Now here, or else what you can do, you can check with the correlation as well. Now guys, what we'll do, we will try to build a model. So for building a model, we have a different algorithm. So let me write it down over here, the algorithm part. So we have sklearn, and from here itself we are going to import the library. So first we have linear underscore model. So this is the model basically we are going to use for the linear regression. Okay, so linear regression. Now here what we have ridge also. Okay, ridge also. And here what we have a lasso. Okay, lasso. Now what I will do, I will be importing different like a model. So what I'm going to do, I'm going to import like random forest as well. So here I'm going to import random forest dot ensemble. Okay, and I need to import it. So I'm going to import random forest regressor. So random forest regressor. So here is a random forest regressor. Now I'm going to use the gradient boosted regressor also. So gradient boosted regressor also. So I'm going to use that one. Let me import it. gradient boosted regression. So gradient boosted regression. Okay. It's not going to do autocomplete. Fine. Now after that, guys, we are going to use we are going to import mean squared error and R square score also. So here I am going to write sklearn dot matrix, and I'm going to import mean squared error, mean squared SQUARD, and here error, and we are going to import R square also. So R2 underscore score. So this is the thing basically which we are going to import, and these are my libraries, okay, which I'm going to use as of now, right? Now here maybe some mistake. Just wait, let me correct the spelling as well. So here is a gradient boosted regression. Okay, I hope it is now clear. So this is my library which I'm going to use. So here what I will do, guys, step by step we'll try to see with respect to each and every column, right? Each and every like model. So the first model which I'm going to use, that is a linear regression. So here I'm going to call I'm going to create a model first, and here is my what is my linear regression. Now what I will do here, I will check with my model 2. Okay, and my model 2 is what? Ridge, RIDGE. Now here what I will do, I will be checking with model 3 barabar lasso. Okay, so here is what? Here is my lasso. Now we have model 4th. So we have model 4th as well. Now here what I will do, I will be using random forest regressor. Okay, random forest, and here regressor. Okay, and we have 4th one also. So we have model 5, sorry, 5th one. So here what we are going to do, we are going to use this gradient boosted regression. So we have this 5 model which we are going to use for our analysis. And now here I'm going to run it. So you can see we have created we just created an object from this model. Now one by one we are going to fit my data. So model 1 dot fit. And if my accuracy won't be good, so what we'll try to do, we'll try to perform some sort of a pre-processing technique on top of the data. Okay, so model dot fit, and here you can see we are going to write model dot fit, model dot fit. Okay, and here also what we have, model dot fit. Okay, and here also model dot fit, right? So here we have model 1, model 2, model 3, model 4, and model 5, right? So what we need to do, guys, see, we have a data over here. Now we have to do split. Okay. So what we need to do, we have to split the data. So here basically, let me write it down, data dot shape. So we have 1000 rows, okay, and 9 column. So I'm going to split my data, and for that I'm doing a random split only as of now. But we have many ways to split the data. If you want to split the data, so you can use stratified sampling, okay. You can use random sampling, or you can use directly cross validation. In the cross validation also we have different kind of cross validation. So generally people use k-fold cross validation. You can go with that, right? So in okay, now here what we can do, we can as of now we are just going to do a simple random sampling. Okay, now for the simple random sampling, what I will do, so for that I'm going to write a train test split, right? So here I'm going to write from model at sklearn dot model underscore selection, SELECTION, and here I'm going to write import train test split. Okay, so import a train underscore test underscore split. Now what I will do, guys, I'm just going to call this function train test split, and here I'm going to pass my data. So my data is what? My data will be X and Y. Okay, that is what that will be my data, and here is my test size. So only 20% data we are going to take as a testing. So my data will be what? 0.2, right? Now after that, what I will do, I will be writing here our X train. I will be writing X test. I'll be writing Y underscore train, and I'm going to write Y underscore test. So this is what? This is my data, right? But here there's asking X and Y is not defined. So what I will do here, guys, tell me, I'm going to write my like a X and Y. I'm going to define my X and Y. So my X is what? My X will be all the column apart from this concentrate concrete compressive strength, right? So I'm going to write over here data dot drop data dot drop, and I'm going to pass what? I'm going to pass like a column. So which column I want to drop? So here I want to drop this last column, right? So I want to drop this last column. So let me take that particular column and let me drop on that particular column. So here is what we have a column and we are going to drop it. Now over here, I'm going to take this particular column as my Y. So here is what? Here is my column, right? Now guys, what I will do here, I'm going to do one thing. So let me take in the double quote this particular thing first of all, and then only I'm going to run it. Okay, because let me check it is working or not. Let me remove this part. I hope it is working. So guys, here you can see if I'm going to show you X, so we have this data only. Now, if I'm going to show you Y, so what we have this particular data. Now, this is what is the random split, right? If I'm again, sorry, this is X and Y, right? Now here you can see we are giving this data, and here if I'm going to run it, so see we are getting X train, Y train, X test, Y test. So here is what? Here is my X train. Okay, this is what is my data, and here is what? Here is my X test, right? So you will find out that this is what? This is my X test, right? Here is what? Here is my data. Now see, we have 199, 760 rows, 112 rows, 253 rows, 34 rows, 330 rows, right? Again, let me run this part. So here you will find out this is going to be changed, right? So here you can see this is going to be changed because it is doing a random split of the data. That's why cross validation is required, or that's why like other sampling technique is required. If your sampling technique is not, if your X train and X distribution is not going to be matched, so definitely again and again you will have to do a splitting until it is not going to be the both pattern testing and training pattern is not same, right? And that is very much required. Okay. uh Many things you will be learning by the time once you will be getting pro in this like a basic thing, so you can go for the advanced thing, or you can explore by yourself also or different techniques and all, right? So guys, here you can see we have extend and xtest. Now after that, what I need to do, I need to fit my data to my models. And where is my model, guys? So here is my model. Let me show you. So this is my models. So guys, still here everything is fine. In which accuracy is more in cross validation of K4? Both are same. RV. I think your basics is not clear. Directly jumping to the project. So first, I would suggest you please go and check with the previous recording, and then only attend the project part. Please explain ridge and lasso burns. So ridge and lasso is nothing. It's a regularization technique. Okay. So in the machine learning, we have three things. So the three thing, which one? So first is what? First is objective function, right? Objective function. So in the linear regression, what is the name of the objective function? Wait, guys. So we have objective function. So the linear regression, what is the name of the objective function? The name is linear line, right? So the simple linear line, y equal to mx plus c. Okay, guys, just wait. So we have linear equation. Then what we have loss. And then what we have optimizer. So this is the basic pipe. This is the like mandatory thing in each and every machine learning algorithm. You will find out. So this is called objective function. All right. This is what, guys? This is what objective function. Now here loss is what? Loss is the function, right? Either MSE, MAE, whatever. Now in this loss, basically what we are doing for reducing the error. Okay. So we are going to use the what we are going to use. We are going to pass basically to reducing the basically to reducing the overfitting. Okay. We are going to add some constant over here, right? So either it will be L1 or L2 or it will be L1 plus L2. So this loss function, let's say you're having MSE, mean squared error. So this MSE, like this MSE will give you what kind of a curve? Tell me. If it is a square or like a function, okay. If it is a square function, so it will give you this kind of a curve. Let me show you. So it will give you this kind of curve, right? Uh, it will give you this kind of curve, right? So this MSE will give you this kind of curve. But here basically see what will happen if you are getting exact curve. Let's say this is the parameter, optimized parameter. Okay. So this is the curve, and here in the local minima, you are getting optimized parameter. Okay. So this might be a overfitting. So what you will do in this square function, you are going to add some value. Okay, so you are going to use L1, L2. This is what is the constant value you are going to use, right? L1, L2, whatever, or L1 and L2 both. So this curve will be deviated. So this curve will be going here like this. So this is your original curve, which is an optimized one, which will give you the overfitting. But if the curve is going to be deviated like this, like this, like this. So here basically at this point of time, you are getting this particular loss, and this is the optimized parameter, right? So this curve basically, this curve is representing a more general thing, right? It is not going to be overfit. What is the meaning of the overfitting? Means your training accuracy will be good compared to your testing accuracy, right? So that is called overfitting. Your data is not going to be overfitting with this kind of curve. If your curve is like this, means you are having zero loss with this particular parameter, with this particular AM. But if your curve is like this, so you are having this AM with some sort of a loss, means you are going to consider some sort of a loss, and you are going to create a generic. What you are going to do, guys? Tell me. You are going to create a generic model. So that is the meaning of Ridge and Lasso. Okay, regularization is very, very important concept in the machine learning. Got it? Yes or no? Just to revise from your previous concept, try to understand some mathematical thing, you will get to know it. Are you getting it now? Yes or no? I explain you the entire concept of the like Ridge and Lasso. Okay, so fine. Now what we can do, guys, we can take 5 minutes of break, and then we'll try to build our model, and we'll check with the different accuracy of the different model. Is it fine? Yes. Just a quick break, a water break. Okay, so let me put the timer for the 5 minutes, and then we'll start again. Here is a complete thing which I have written over here. First, we'll try to build the model and we'll check with the accuracy. If I will be getting very less accuracy or something wrong with my model, again I will come to my data. I will do a EDA. I will perform the EDA, and then I will do a pre-processing. Okay. So let me put the timer for the 5 minutes, and again we'll start with the session. So just give me a quick yes or no in the chat, guys. Yes or no, please tell me. Okay, fine. So just a quick break. Okay, so guys, can we start now again? Yes or no? Tell me guys, can we start? Or do you want more break? Okay. So fine. So guys, here we can check with the different models. Okay. So how we can check over here? Tell me guys what I need to do. I just need to pass the data. So let me write it down the data over here. X train, uh, Y train, and that too I'm doing with every model. So here is what, here's my X train, Y train, here's my X train, Y train, here's my X train, Y train, and here is my X train, Y train. So let me train my model. So here I have trained my all the models. Can you see guys? Yes or no? Yes. Now what I need to do, I just need to fit the data. Sorry, predict the data. So for the prediction, here I just need to take a models. Okay. So model 1 and model 2, 3, 4, and 5. So I'm going to take a 5 model, and here I need to predict the data. And then finally, what I will do, I will check with the accuracy. Okay. So here is what, here I will check with the accuracy. So should I consider the data leakage concept? Am I right? Yes, that comes basically whenever you are doing retraining. So whenever, like, once you are going to create the model, and then you need to check with your model, right? It is working, means after some time. Okay, what you will do, you will be checking my model is performing well or not. So the new data, whatever new data is coming, so that data and the previous data, with that you're checking the difference. Okay, so if there is any difference or there is any drift in the data, right? So that thing you are going to detect generally while you are doing a retraining of your model. If feature are not distributed normally, should I transform them for this project? Yes, RB. If feature is not like a distributed, so you have to do a transform those particular feature. Now model 2, now model 4, now model 5, and model 1. Now here I need to predict it. So predict, and I need to write something. So predict. Okay. Now here I need to write predict. Okay. So here also I'm going to predict. So predict, right? And here also I'm going to write predict. So, and what I need to predict, guys, tell me. I need to check with the model 1, right? Sorry, I need to check with the X test. So here I'm going to write what? Here I'm going to write X underscore test. Let me copy this X test, and let me paste it over here. So X test, and this is what X test. Now what I will do, guys, here I will write prediction. So why predict? So why predict first, and rest of the values I can write it down. Why predict 2, 3, 4, and 5. Because I'm checking with the 5 model, so definitely I will have to do it. Rest of the model, and here is what, here is my last one. So this is what, this is the last one. Okay, model 2, model 3, model 4, and model 5, right? So guys, now here I got a prediction. If I will run it, I will be getting a prediction. So here you can see I'm getting a prediction. Now I can check with the accuracy, or I can check with the R square value. Sorry, mean square error or R square value. Anything is fine. So I'm going to call that. Okay. So here is what, here is my mean square error, right? Now mean square error, first, second, third, fourth. See, for that, basically I can write the code as well. I can automate this process, but as of now I'm just going to implement the Jupyter notebook. So I'm showing you like this. I can write a code, I can automate the entire process. We have many things, we have many library. Okay, AutoML, and for the AutoML we have lots of a pre-built library also, built-in library also, we can use those also. But as of now, I'm just showing you this process, a basic process. So that's why I'm writing like this manually, right? Otherwise, I can do this automated also. This particular task I can perform by the different library, right? So this is what, this is why one predict 1. This is 2. This is what 3. This is what 4, and this is what 5. So I got the MSC also. If I'm going to run it, definitely I will get the MSC value. So here, let me print this MSC value, and now let's check what will be the values. So here is my MSC. Let me copy it, and I'm going to print how many times? 5 times. So here is what my second, fourth, and fifth. And this is my MSC first, this is my second, this is my third, right? This is my fourth one, and here is what? Here's my fifth one, right? Now see guys, how much MSC I'm getting with respect to the like with respect to this I would say models. So 103, 103, 102, 17, and 20. So guys, tell me which model like you are like getting fine. So which model? First, second, third, and fourth, and fifth. Tell me guys. So let me write the name as well along with the model. So here I can use F string. So here I can use the F string to like represent or to showcase the values. So here's the value. Let me write it down here. Uh, Sorry, this is my like a string. So the first model was linear rich lasso. So here is what linear. Okay. And here is what it will be inside this one. Then what we have rich, right? And then we have this one. Then we have lasso. Then we have this, right? Then we have this one, random forest. And we have this MSC, MS4, right? Now we have gradient boost. And this MSC 5. So if I'm going to run it, now you will find out. So here we have these two one, right? These two, random forest and which one? Gradient boosting. So in that also we are having random forest, which is giving me a like a less MSC. And the same thing we can check with the R square also. So you know R square, what is the R square? Tell me guys, you know what is the R square, right? So we can check with the R square also, the same thing. Now let me do one thing over here. Let me write it down the R square. Okay. Root mean square value, no need to check with that because here maybe basically we are using this MSC formula. Okay. So in the like loss function in the gradient descent, basically we are using this MSC formula. We are just going to validate our model with this MSC only, right? No need to check with the no need to check with that one. So R2, and here I can write linear. Here I can write and I can copy 5 times the same thing. Okay. And here I can check with the Y predict 1. Here is 2, here is 3, here is what, here is 4, and here is what, here is 5. Now here linear regression, here is what, here is my ridge. Here is what, here is my lasso. And here is what, here is my random forest, RF, I can write RF. And here is what, here is my gradient boost, GB, right? So this is what, this is my R square value. Now let me print this also. So here I'm going to take this. Now instead of this one, I'm going to take this linear. Okay. Now this one here. This one also here. This one also here. This one also here. And this one also here, right? Now here what we have ridge. Let me remove it. RIDGE. Now here what we have lasso. So LASSO. Now here what we have RF, random forest. Okay, RF. And here what we have gradient boost, GB, right? GB. So let me run it and let's check the R square value. So here, see, with respect to this random forest and gradient boosting, we are getting this R square 0.93. So if my R square value is near to 1, R square value is near to 1, R square near to 1. So that model will be considered as like a good model. So here R square value, we are getting R square 0.93 for the random forest. So my random forest will be a best model over here. Got it guys? Yes or no? Tell me. Yes. Yes, here random forest is the best model. What do you think? And are you getting my point guys? Yes or no? Please let me know in the chat if everything is fine and if you're getting everything here. Mm. Tell me guys fast. AUC ROC curve for this, how I can explain that we use for the classification problem now. Do we use like this ROC UC curve for the regression? See guys, see, before coming to the project, please clarify your basics. I request to you. For this one, I cannot create ROC UC curve because it is not a classification problem. It's a regression problem statement. And the metrics will be different for the regression problem statement. Got it? Yes or no? So guys, if you don't know the basics, if your basics is not clear, I would suggest you go and check with the previous classes before coming to this project. How will compare R2 and mean square error? See, mean square error is just like a what is this? The difference between predicted and the this original one. Okay, R square. For the R square, the formula is different, right? What we are doing with respect to the our average value, average line, we are going to analyze the best fit line. So just check with the formula. Okay, so we can find out the loss. We can analyze our model based on the loss directly or based on the R square value. There we are taking a reference of the average value. And for the average value, basically that is the worst one for our like a model, right? So if it is going to be matched with that, the R square will be 0, means our model is completely based with respect to the linear data, right? So guys, just try to understand these things. And machine learning is is not only about the scikit-learn, sklearn. You are just going to import the model. You are going to creating a model. You are just doing a simple analysis. Not like that. It's more than that. So understand each and everything in detail, I would say. So here, which is my best model? As of now, my best model is random forest. So we are going to use this model for our production. Now, guys, tell me here, can we do something? If okay, just tell me, just at least tell me 5 pre-processing technique. What all thing we can do? I'm giving you 2 minutes of time. Just write it down the chat. Then I will tell you what all changes you can make inside this particular analysis. First of all, tell me. Your thoughts. So, what do you think? What we need to do with this particular project? What all pre-processing technique we can add on over here? Tell me, please. I'm giving you 2 minutes of time. I'm just taking break. Okay, just write it down the chat until. Okay, so guys, I got many answers in the chat, and few are very, very good. Few are like very disappointing. Okay, so here I can see many answers. BD has given me a few suggestions, few steps. Akshay, Durgesh, RV, Devjyoti, not others. Is what you are doing? Why you are not writing in the chat? I can see many people has joined. Okay, just write it on the chat. What thing you suggest? If I want to increase my accuracy from a 93 to, let's say, a 98 or 98 is like too much, but let's say 97 or 96, then what should I do in that case? Maybe PCA as well. PCA. Yes, so at least do the hyperparameter tuning. Correct. That is a one thing which we can do. What we can do, we can perform the hyperparameter tuning. What about others? Why people are not like telling? So write it down in the chat, guys. Because I want to see your thoughts also. What do you think? Fine. So see, many people are saying this, that, whatever. Now one answer I got. Sajat is saying import libraries, data cleaning, missing value. Guys, just tell me, do we have missing value in this data? Are you focusing on the session? Do we have missing value? I shown you at the first place only. So see, I shown you here itself. We don't have any missing value. Then how we can handle the missing value? We cannot handle, right? So here, missing value we cannot handle because we don't have any kind of missing value. Okay, let me write it down here. What we cannot, what we can or we cannot do, right? So the first thing, don't handle missing value because we don't have that. Don't handle missing value. The second thing is what we can do. You guys just wait. Just wait. Okay, so here guys, what we can do, we have don't handle the missing value because we don't have that, right? The second thing, no need to do encoding as well. So encoding is not required because all the value is already in the numeric format, right? So here you can see like encoding is not at all required. So the first thing is what? So don't handle missing value and encoding is not required. The thing basically which you can do over here. So you can check with the scaling, right? You can perform the scaling of the data. The second, the before that, basically what you can do, you can handle the outlier as well. Because when I was checking with this distribution of the data, then what I felt over here that we might have some sort of an outlier in the data, right? So you should handle that kind of a those kind of outlier. Okay, so here it is outlier. So you should handle the outlier, but the data size is very, very small. So don't go with that directly, means don't drop the outlier and all. Just try to impute that, means we have many methods to handle the outlier without dropping. Also we can like take care of the outlier. So just try to explore those kind of technique, how we can do it, right? So here what you need to do, so here you need to handle the outlier, right? So here let me write it down, handle the outlier, handle the outlier. Okay, handle outlier. Now you need to do a scaling also, because see here, whenever I'm checking with the data and whenever I'm seeing the data, so I like I'm feeling that there is like lots of difference basically in the like a scale of the data. So here you will see the scale is different and here you will see the scale is different, right? So you need to do a scaling of the data. If you are doing that, you might get a good result uh, with the linear regression as well. Why you are not why you are not getting good result with the linear regression? Tell me why. Because there you didn't perform any kind of a scaling. You didn't perform any sort of a scaling. That's why you're not getting a good result with the linear regression. And linear regression always required a scaling, right? So that is the second thing which you can do. Now, what you can do after that? After that, you can do a hyperparameter tuning, means you can find out a best parameter for your model. You can find out best parameter for your model. Outlier handling is required. For that, you can use Optuna or anything, right? Now, apart from that, what you can do, so here, you can remove the duplicated value. Okay, so remove the duplicate value. So what you can do, guys, you can remove the duplicated value or impute that. So or impute that. Anything you can do with respect to that. So you can impute the value, impute the duplicate value, right? That is the thing which you can do. Now, after that, what you can do, you can work on the splitting technique also. So we have, so in that basically what we have, what we have done, we have splitted our data with a random, we took the random sample, right? Now here you can take another technique, right? So take another technique for the split, for the splitting, okay, and or use cross validation, right? Or use cross validation. So the fifth one is what? Take another technique for the splitting of the data and use the cross validation. So the fifth thing, fifth one which you can do, or else what you can do, try another algorithm as well. Try another algo uh, algorithm as well. So if you are going to take these many steps, so definitely you can increase your accuracy from 92 to maybe 98%, right? So that is a thing which I want from your side, right? So what I'm doing over here, so scaling is done when units are different, but almost all the units are same. Unit are same, but the values is different, na? Why we do scaling? To make the data in a same like a range, or to just to small up the value, that's it, right? If let's say you are having a value, mm, here is you have written, this is the what, this is the distance, right? And this is what, this is the let's say currency, okay? So here let's say the distance is what, this the distance is like, let's say 5 kilometer. Here the currency is what, let's say, here I'm going to write, let's say the currency or the rupee, whatever is there, let's say 5,000 rupee. Okay. For the 5 kilometer, there is 5,000 rupees. Let's say there is 10 kilometer. Now the rupee is going to be let's say 20,000. So here you can see what is it? The unit is different, right? Unit is different. And whenever we are passing this data, it doesn't matter there is rupee or kilometer. We are just going to be deal with this numeric value, right? So it should be scale up. Means I don't want to be my graph like this. Means let's say on this graph we have 0, 1, 2, 3, 5, okay, and here 6, 7, 8, 9, 10. So let's say one point is here 5 and one point is this 10, and with respect to y-axis, tell me, it will be very far. So here somewhere we will be having 5,000, right? 1,000, 2,000, 3,000, 5,000, and then somewhere will be 10,000, 20,000. I don't want to do this. I want to be scale up this value. Means I want to be small this particular values, right? Within one, between 0 to 1, or between, I want to do standardize this particular value. Means zero centric, right? Zero centric means the mean should be zero, right? So this thing is not going to be impact. We are going to deal with these values, and if this value is very large, so you can do a transformation with respect to this particular values. I hope you got it. Now guys, here these many things you can perform with respect to your data, right? Now what is your homework over here? So the homework is the data, the use case basically which I solve in front of you, a very basic one. Nothing is there. Our data set was also very simple. Now you need to increase the accuracy. So right now you are getting accuracy. You are getting accuracy. How much? 93%, the maximum one, right? 93%, right? 93%. Now here I want a 98% accuracy, 98% accuracy, 98% accuracy, and I don't want like a overfitting over here. Okay. Now give me the condition of the overfitting. What is the overfitting? Now give me the condition of the overfitting. Now what is the overfitting? Tell me guys. What is the overfitting? What do you understand with the overfitting? Tell me. The overfitting is what? Overfitting means, tell me guys fast. I'm waiting for your answer. Training accuracy is high and validation accuracy is, tell me fast. Training accuracy is high and testing accuracy is low. So what is the overfitting? Overfitting means predicted model work better on the trained data. Now guys, see, you can ask me one question over here that Sunny, you didn't show me over anything over here. Means like you didn't show me anything with respect to the trained data. Here, this is the thing basically with respect to the test data. But what about the training? So let me show you the with respect to the training also. So we have model 4, and here what I'm going to do, I'm going to print score for the from the model 4. So model 4 dot is score, and is scored with respect to what? With respect to my training data. So here what we have a x train, x underscore train, and what here we have y underscore train, right? Y underscore train. So here what I'm getting a score. Let me show you, and I'm getting 98%. Tell me guys, this is the overfitting. Means my training accuracy is this much, and here is what? Here is my testing accuracy is 93%. What do you think? This is the overfitting? Is it here? I don't think so, right? Yeah, so that is what I want. Means I don't want too much difference. Okay, so let's say if I'm getting let's say 60% accuracy here and 93% accuracy on my testing data. In that case, it's the overfitting. You can check with the model 1 over here. Yes, definitely. So here model 1 is score. So what I'm getting 60%. Now tell me here. So here what I'm getting 61%. Let's say I'm getting 61% with respect to model 4, and here I'm getting 93% with respect to model 4, the testing accuracy. So what is this? What you will say? See, training accuracy is high, testing accuracy is low, overfitting. Training accuracy is low, testing accuracy is low, underfitting. Training accuracy is low, and testing accuracy is very, very high. You won't find this kind of scenario. Okay, believe me. And if you're getting this scenario, this also comes inside the underfitting. Correct. Okay, it's not overfitting. Underfitting means my model is not able to fit well on the data, right? So fitting means what? Fitting in terms of data. Fitting. Now it might be over or it might be under. If it is over, means it is well fitted on my trained data. If it is under, it is not fitting on my trained data. Okay, this fitting is basically everything is related to the training only. So just try to keep this keep this thing in your mind, and you may understand in a better way, right? So guys, now what you can do, you have to increase this particular accuracy from 93 to 98%. And here I don't want overfitting. Means your training accuracy between your training accuracy and testing accuracy. Okay, there should not be much difference, right? So between your training accuracy and testing accuracy, there should not be much difference, right? Much difference means how much? So there should not be difference more than 5%. More than 5%. So you have to keep this thing in your mind, this particular constraint, right? And you have to apply these many steps. Okay, you have to try, and you need to increase the accuracy. All right. And yes, so I will give you the chance to explain the same thing in here itself, and definitely you will get some sort of a benefit from our side as well. Means if you are a good student, that definitely I will recommend your name to my team, and you will get some sort of a gift voucher on something. So let's go for some sort of a gift. Okay, so that I will tell you in the next session itself. If you are going to represent me this thing, so definitely you will get something from my side. Okay, so yeah, that thing I will let you know in the next session. So what you need to do, you need to implement it and you need to increase the accuracy. And this thing is not required because uh, the value is already encoded one and we are not having any kind of any kind of missing value here. Okay. So this thing you need to perform. And guys, in the next session, we are going to solve. So I will give you half an hour to explain you this thing. At least 2 to 3% definitely will be there. So half an hour or more than that maybe. And it might be an interesting one. If you solve like this one sincerely, right? After that, what we'll do, we'll try to solve one more like a use case, that is a visibility climate. Visibility climate. Right? So we'll try to solve one more use case, that is a visibility climate. And in that, again, I will try to implement in front of you each and everything. And in that I will go in the detail. And plus, we'll try to changes, we'll try to do some changes in our pipeline also. So plus, I will tell you, I will give you complete overview of MLOps tools, right? So we are having different tools for the complete MLOps pipeline for the MLOps, right? So we'll talk about those tools also. So visibility climate plus like a different tools, and then you need, based on that, you need to change the architecture of the project, right? So this will be the agenda for the next Friday. So here, next Friday, half an hour discussion on this particular problem statement, and then basically we are going to complete this thing. Got it, guys? Yes or no? Please tell me in the chat if everything is fine and if it is making sense to you. Tell me. Yes. Any doubt, anything? If you're having any doubt, please let me know. So we'll be having next class on next Friday. Yes, tell me, guys. I'm open for the doubt. If you're not having any doubt, then I will close the session. We'll see. So how you are going to perform on those like on these steps for the hyperparameter tuning, outlier handling. Okay, based on that, I will share my solution. Please share your LinkedIn ID so you can search Sunny Savita. I think that will be the first person in your search list. This is the person. Okay, I can share the ID. Fine, guys. I think we are good now. Tell me fast. Can we close the session? Okay, so guys, will connect on next week and at the same time, or time might be a different one. So guys, can we have session in afternoon or maybe in evening, early evening, let's say 4 or 5? Tell me, can we have a session at 4 or 5? What do you think? What do you say? Please let me know in the chat. Because I'm having another class as well. That's why I'm saying. Next week, basically 5 or 7, 5 o'clock. Is it fine at 5 o'clock? After, see, from 8 o'clock, I'm having another session because I have to take data science in the PPT as well. So maybe I will be involved in that. 9 to 11, 4 to 6. 4 to 6 is fine for you? Or should I keep on weekends, morning 10 to 1? Tell me, 10 to 1 or like this 4 to 6? Weekend, Saturday, Sunday, 10 to 1. 4 to 6. Okay, how many people are saying for the weekends? Please let me know in the chat. Should I keep on weekends on or should I keep in weekdays itself? 4 to 6. But weekend, this weekdays time 4 to 6 only. Tell me. Weekends both okay. I prefer weekend. Hmm. Weekend ML bootcamp is there. So, okay, guys, you will get a mail from my side. Okay. So either it will be on weekend or weekdays, you will get a mail. Could we stick to the session as we wanted lots of time for learning? We can build and resolve issue at our end, but you are not doing that. Now, I given you one task in the last session, you haven't completed. See, if you are in my class, I will give you more and more tasks, and the task will be like this. And whenever you will go in a real time or for the real interview and all, they will give you this kind of a task. And I know better. Means I attended many interview and I solved many case studies as well. So whatever I'm doing, whatever I'm giving you, just solve that, and I will give you lots and lots of tasks. And this live session, let you know till when it will be there. So don't worry. And if you want to connect with me as well, I'm like open for you. You are having my mail ID, email ID, or my LinkedIn profile, everything. So you can connect with me anytime if you are having any sort of a issue. Right. So guys, timing or the session timing basically will get through the mail. Until that, just wait, and whatever thing I have given you, complete that. And once you complete, let me know. You can send me on my mail ID. So sunny.savita@pw.live. So here is my mail ID and here is my GitHub link. So one person was asking, that's why I'm sharing. Here is my GitHub link, guys. Okay, fine, guys. So we can conclude the session now, and we'll meet you in the next session next week, and the timing and the day, basically at which day we have a session, you will get to know, right? So thank you, guys. Thank you. Bye bye. Take care. Have a good night. Good night. Bye bye. Okay, I'm going to conclude the session now. If you are having any doubt, please let me know. You can write it down to me in the LinkedIn or as well as in my mail ID. Thank you.